Okay, I have a refresher on alkanes, alkenes, alkynes, because who remembers anything after a beautiful 3-day weekend? So what you need is table P and table Q. So I'm going to focus on table Q. So there are 3 homologous series you need to know. There are alkanes, alkynes, and alkenes. Alkanes, alkenes, and alkynes. Alkanes are, they all have a single bond between carbon atoms. So if I draw 3 carbon atoms, they all have a single bond. And carbon has to be surrounded by 4 bonding sites. So remember, one line represents one bond, which represents a pair of electrons or 2 electrons. So the first carbon needs 3 more bonding sites to have 4 surrounded. So what we're going to do is just fill them with hydrogens. And soon you guys are going to be drawing all of these on your own and naming. That's what's coming up next. Okay, so this is an example of an alkane that has 3 carbon atoms. If I add up all the carbons, I get 3. If I add up all the hydrogens, I get 8. This formula follows the general formula here, which is CnH2n plus 2. So that just means if I have 3 carbons, I'll have 2 times 3 plus 2 hydrogens. So I'll have a little bit more than double. Alkenes, for this class anyway, will have a double bond. Doesn't matter where it is for now. The first carbon, notice, still needs 3 hydrogens around it to have 4 bonding sites. Sorry, that bond is not very good. The second carbon only needs 1 hydrogen, and the last one needs 2 hydrogens. So again, all I'm doing is making sure there are 4 lines or 4 bonds around each carbon atom. If I add up all the carbons, I have 3 still. And if I add up all the hydrogens, I have 6. So alkenes have this general formula, which means you have twice as many hydrogens as carbons. So that's what makes that an alkene. And then lastly, alkynes have 1 triple bond for our class between the carbon atoms. So the first carbon would only need 1 hydrogen to have 4. The second one is already satisfied. It's got 4 bonds around it. And then the last one would need 3 hydrogens. So you're taking away hydrogens as you're adding more bonds between the carbon atoms. So this one would be C3H4, which follows the general formula of an alkene, CnH2n minus 2. So alkenes are homologous of one another. So if I drew one with 4 carbons around it, it would be homologous of the one with 3. Same with alkenes or alkynes. And then lastly, let's just do a little bit of naming. So they all have 3 carbon atoms. And if you look on table P, 3 carbon atoms means prop. So the first one would be called propane. So prop for 3 carbons, ane because it has all single bonds. The second one would be called propene. Actually, it's going to have a number in front of it, but for now we'll keep it like that. And then the last one would be called propyne. Have a wonderful day. Stay cool.